Welcome, chemistry students. Let's get right to it. If you've got an exam looming and you need to absolutely nail the concepts of pH, acids, and alkalis, well, you're in the right place. We've built this explainer to be your ultimate cheat sheet. We're going to cut out the fluff and zero in on exactly what you need to know. Okay, imagine this. You're standing at a lab bench, and sitting right in front of you are 3 beakers. They all hold crystal clear liquids. Seriously, they look exactly like tap water. But here's the catch. One is pure water, one is a highly corrosive acid, and the last one is a potent alkali. If you guess wrong, yeah, you really don't want to guess wrong. So how do you actually tell them apart? Well, it all comes down to chemistry's ultimate tattletales. Here's our game plan for today. 1. Introduction to indicators. 2. The pH scale defined. 3. Reading universal color charts. And 4. Testing acids in daily life.
Section 1. Introduction to Indicators. The chemical tattletales.
So here's a foundational definition you absolutely need to memorize right now. An indicator is simply a substance that turns one color in an acid and a totally different color in an alkali. Think of it kind of like a chemical mood ring. If you drop a little bit into those mystery beakers we just talked about, the liquid will physically change color right before your eyes. Bam! Mystery solved. The absolute classic example here is litmus. Now, litmus is actually a natural dye, and we usually soak absorbent paper in it to make litmus paper. Here's your golden rule for the test. Litmus turns red in acids and blue in alkalis. Acid, red. Alkali, blue. Definitely burn that into your brain. Oh, and if it's perfectly neutral, like our beaker of pure water, the paper turns a nice purple. Now, the really cool thing is that these indicators aren't just cooked up in a lab. They're actually hiding out in nature. Take red cabbage juice, for example. When you drop it into hydrochloric acid, boom, it instantly flashes this brilliant red. But drop that exact same cabbage juice into sodium hydroxide, which is an alkali, and it turns yellow. Same cabbage, totally different chemical reaction.
Section 2. The pH scale defined. Measuring the strength.
So we know how to spot an acid or an alkali, but how do we measure their actual strength? We use the pH scale, and this scale runs from exactly 0 to 14. Think of it as a ruler for chemical properties. Down at the lower end, you've got your acids, and up at the higher numbers, you've got your alkalis.
Right smack in the dead center of that 0 to 14 range is the number 7. In the chemistry world, a pH of exactly 7 means the substance is perfectly neutral. Not acidic, not alkaline, pure water sits beautifully right here on the scale. Let's lock this in with a quick cheat sheet of common stuff you're practically guaranteed to see on your exam. Hydrochloric acid turns litmus red because it's a strong acid. Lemon juice, we all know it's super sour, turns a universal indicator yellow, making it weakly acidic, around a pH of 4. Good old water is perfectly neutral at pH 7, so it turns litmus purple. And sodium hydroxide turns litmus blue, proving it's a solid alkali. Seriously, take a mental screenshot of this.
Section 3. Reading universal color charts. Decoding the rainbow.
Okay, while regular litmus paper is great for a quick yes or no, a universal indicator is a whole different beast. It's actually a clever mashup of several different indicators. Because of that, it doesn't just flip between 2 colors, it displays a whole spectrum, a literal rainbow, to give you an exact pH number. Pro tip for the exam, warm colors like red and yellow mean acid. Green always means neutral, and cool colors like blue and purple, those are your alkalis.
Let's attach some hard numbers to those colors so you can match them perfectly on test day. If that universal indicator turns a deep, angry red, you're dealing with a strongly acidic substance, like a pH of 1. If it's yellow, it's weakly acidic, maybe pH 4. Green, that's our safe, neutral pH 7. A nice blue means it's weakly alkaline at pH 10. And a dark, rich purple means it's strongly alkaline, hitting around pH 13.
Section 4. Testing acids in daily life. Bring the lab home.
If an exam question asks you to list the methods for testing acids and alkalis, here's your 3-point answer. 1. Litmus paper. Remember, this just gives you a basic acid or alkali reading. 2. Universal indicator, which comes in liquid drops or paper strips to give you that precise pH number. And 3. DIY plant indicators. Believe it or not, brightly colored stuff like red cabbage, beetroot, and even black currants naturally contain the exact chemicals needed to act as indicators.
Let's quickly walk through how you'd actually make one of those DIY plant indicators in the lab. First, you chop up the plant and toss it into a mortar and pestle to crush it up. Second, you add a splash of ethanol. Now pause, massive safety checkpoint here. Ethanol is highly flammable, so you absolutely must read the hazard labels and wear your safety glasses, period. Third, keep crushing until all that rich color bleeds out into the liquid. Finally, grab a pipette and carefully transfer your new, colorful indicator into a test tube.
It really helps to visualize the actual equipment when you're trying to memorize these steps. Just picture it. The chopped plant sitting in the mortar, the pestle grinding it down, carefully adding that highly flammable ethanol, and then delicately drawing the final liquid up into a pipette before dropping it into the test tube. And just like that, we've wrapped up our rapid-fire review. You've got the definitions, the 0 to 14 scale, the color charts, and the lab methods all locked and loaded. But before we go, I want to leave you with a bit of a challenge. Based on everything we just covered about plant indicators and the pH spectrum, do you think you could build a fully functioning pH chart from scratch using absolutely nothing but a red cabbage and the everyday liquid sitting in your kitchen right now? Think about it. Good luck on those exams, and keep on learning.